Hi students, this is Mrs. Myers with a video on solving equations. We have been working with models, bar models, as well as algebra tiles to model equations, and today we're going to talk about how to solve equations. So you should have your handout in front of you. We're going to start out with the page that has equations involving addition. So you're going to need to find where this is in your foldable. You should have two sheets, but find the place where the title at the top is equations involving addition, and this is where we're going to begin. All right, let's look at the first equation. We have y plus 6 is equal to 9. So we're going to go ahead and start working with this problem. So just like with the models, what we're trying to do is we're going to try to isolate our variable. So we're trying to get y by itself. And so I'm going to draw a line down here to represent both sides of the equation. And in our model, we would have had a variable or a picture, and then we would have 6 units, and then we would have 9. So what we would need to do is to get rid of the positive 6, and the way we get rid of that is adding a negative 6 or subtracting 6. And so when I do that, the positive 6 cancels out, and now I've isolated my variable, and y is equal to, and 9 minus 6 is 3. One of the things I also want to do when we're working with these equations is I want to learn to get in the habit of checking them. So we're going to go ahead and look at how we would check this equation. So if I know that y is equal to 3, to check it, I'm going to substitute 3 for y. So 3 plus 6 equals 9. And then I'm going to see if that's true. 3 plus 6 is 9. 9 is equal to 9. So this checks. So all I'm doing again is I'm taking whatever this y value is, what I got for my answer, which is 3, and I'm plugging it into the original equation and rewriting it to check it. All right, let's take a look at the second example. We have x plus 3 is equal to 1. So we're going to start the same way. I'm going to put a line down here to separate the sides of the equation. And I'm trying to isolate my variable, which is x. And I'm trying to get rid of that positive 3. So I'm going to subtract 3 from both sides. Okay. The negative 3 cancels out the positive 3. And I'm left with x is equal to, and then 1 minus 3. If I do that on my calculator, I'm going to get negative 2. So again, just like the last example, I'm going to go through and check it. I'm going to do my check. And so I found that x was equal to negative 2. So I'm going to simply put negative 2 into the equation. Negative 2 plus 3 is equal to negative 1. And not negative 1. The original equation, remember, has positive 1. So this is actually going to be negative 2 . Yeah, it's going to be negative 2 plus 3 is equal to positive 1. And if I add negative 2 and positive 3, I'm going to get 1, and 1 is equal to 1, so this is check. And again, I just took this equation and I substituted my answer, negative 2, which is what I got for x, into my original equation. Okay, you're also going to have variables where equations where the variable is on the other side. And that is doable. So we're going to take a look at number 3. I'm going to put a line down. And now you have the variable on the right. So we're trying to get a by itself. And so if you look on the right-hand side, you have positive 4. So I'm going to subtract 4 from both sides of the equation. Okay, and when I do that, on the right, that positive 4 and negative 4 cancel out, just like we saw with our models. So I'm going to bring down a, And then negative 3 minus 4. I can put that into my calculator if I'm unsure. Negative 3 minus 4 is negative 7. So my answer for that equation is negative 7. So I'm going to go through and do my check, just like I did with the last few problems. So I'm going to write the equation. Negative 3 is equal to, I'm going to substitute negative 7 for A. Negative 3. Okay, we're just rewriting this equation down here, substituting our A value that we got. And then if I add negative 7 and 4 together, I get negative 3. So that's going to check. And again, the A is the negative 7. So it's going to check. All right, let's take a look at the next problem. We have negative 14, or excuse me, 14 plus m is equal to 20. So this time the number 14 comes before m, but it's still a positive 14. So since that's a positive 14, to get rid of it, I'm going to add a negative 14. So I'm going to add a negative 14 or subtract a positive 14 from both sides. When I do that, 14 minus 14 gives me 0. I bring down my variable, which is m, and m is going to be equal to 6. And just like in the last examples, we're going to go through and do the check. So I'm going to rewrite my equation. 14 plus 6 equals 20. 14 plus 6 is 20, and 20 is equal to 20. So this one checks. All right, let's take a look, and again, oh, back here, this 6, just so that you guys see what we're doing. We're taking this original equation up here, and I'm just rewriting it with what we got for m to check it. So for number 5 is a little different because now we have verbs, and excuse me, now we have words. We have verbal equations instead of algebraic equations with numbers, and we're going to go ahead and translate that. So let's take a look at how we would do that. We did some of this when we were working with expressions, and now we're going to do the same thing with equations. So let's think about the sum of a number and 3 is negative 2. Okay, so we know that sum is going to be plus. If I don't know a number, we're going to use a variable for it. So we're going to use, in this case, n. We know we're adding the sum of a number and 3, so we're going to represent the 3 here. And this is, okay, so the word is going to be our equal sign. And we know it is negative 2. So now we're going to put all of that together. Okay, so we know it's the sum. So I'm going to take my plus sign. I'm adding. What am I adding? I'm adding n and 3. That's the sum. And together, they're equal to negative 2. So now we've written our equation. So it's n plus 3, the sum of a number and 3, is negative 2. So now we're just going to solve it, just like we did the ones above. So to solve it, we're going to do the same thing. I'm going to take my line down here so I can look at the two sides of the equation. I'm trying to isolate my variable, which is n. So I'm going to subtract. I've got plus 3, so I'm going to undo adding 3 by subtracting 3 from both sides. This is going to cancel out. And then n is equal to negative 2 minus 3, which is negative 5. So that's my solution. But now let's try our check. So our check, we're going to do over here on the right. So if negative 5 is n, I'm going to rewrite this equation. Negative 5 plus 3 equals negative 2. Negative 5 plus 3 is negative 2. I can confirm that in my calculator. And negative 2 is equal to negative 2. So that one checks. And these are all examples that equations are involving addition. And to undo addition, we are going to subtract. Or undo adding a positive, we're subtracting a positive. Or adding a negative. Okay, you can think of it either way. So now that we've done some equations involving addition, let's look at some equations that are involving subtraction. So on our next page, find these problems. You should see the title, the heading above it saying equations involving subtraction. So let's get started with the first problem. We have x minus 2 is equal to 1. Put a line down here. And remember, I'm trying to isolate my variable. And I'm subtracting 2, so I undo subtracting 2 by adding 2. So I'm going to add 2 to both sides. And when I do that, this cancels out, and x is equal to 3. I'm going to rewrite my equation by substituting 3 in for x. So 3 minus 2 equals 1. 3 minus 2 is 1. So 1 is equal to 1. So my equation stayed balanced. It checks it's correct. All right, let's look at the next equation here. Now we have y minus 3 is equal to 4. So we're going to put our line down to help us keep everything organized. I'm going to highlight my variable so I can remember where I'm isolating and I'm undoing what's been done to the variable. So I'm subtracting 3, so the inverse of subtracting 3 is adding 3. So I'm going to add 3 to both sides, and y is going to be equal to 7. There's 4 plus 3 is 7. This over here cancels out. So again, I'm going to do my check. And I'm going to get 7 minus 3 equals 4. Let's see if that's true. 7 minus 3 is 4. 4 is equal to 4. It checks. All right, now we're going to get into the problem. You'll notice from number 8 that we do have more negatives here. We have a negative on the right side. So, same thing though. I'm taking 4 away from r, and I should get negative 2. So again, I'm going to highlight my variable. And I'm going to undo the subtraction of 2, or excuse me, the subtraction of 4. And I do that by adding 4 to both sides, because our equation needs to stay balanced. When I add 4, when I undo the subtracting 4 by adding 4, that cancels out. So I bring down my variable, which is r, and negative 2 plus 4 is 2. There's my answer. Now I'm going to plug it in for my check. So I get 2 minus 4 is equal to negative 2. Let's see if that's true. If I, in my calculator, put 2 minus 4, I'm going to get negative 2. So negative 2 is equal to negative 2, so it checks. So these are all one step, and they are a review from 6th grade, but I want to make sure that you guys understand the steps needed for adding and subtracting, or addition and subtraction equations, before we get into two-step equations. So let's take a look at the last problem here. So we have negative 9 is equal to q minus 8. So again, this time we have the variable on the right, but that's okay. So now we're going to focus our attention on the right side of the equation. So we're going to undo subtracting 8. So what we're going to do is we're going to add 8 to this side, and we're also going to add 8 to this side. This cancels out. And then negative 9 plus 8 is negative 1. Negative 1 is equal to q. So I'm going to rewrite the equation using the solution that we found for q. And we're going to say negative 9 is equal to q. Oops. We don't want q. We want to put in the value for q. So let's try that again. So we're going to put in negative 9 is equal to negative 1 minus 8. So negative 9 is equal to negative 1 minus 8. If you put that in your calculator, you'll get negative 9. So that one checks as well. Okay, let's look at number 10. We have another example where you are decreasing a number by 4, and you have verbal, you have a sentence this time, and you're going to translate that into a subtraction equation, and then you're going to solve it. So we're decreasing a number by 4. Okay, so when you decrease, we're subtracting. Let's think about what we are subtracting. We're subtracting a number. You're decreasing a number by 4. So we're just going to put the 4 here. And then we have the words is the result, or the result is. So the result is would be our equal sign. So the result is, we're going to use equal for that. And we can see here that the result is negative 5. Okay, so let's put all of that together, just like we did with the addition equation example. And we're decreasing a number, so we're decreasing the number by, so we're taking 4 away, we're decreasing it by 4. And the answer, or the result, it tells us, is going to be negative 5. So now we can solve it. Put our line down the middle. We're going to add 4 to both sides. This cancels out. I'm going to continue it over here on the right so we have more room. So n is equal to negative 1. That's my solution. Now I'm going to plug it in to my equation. So negative 1 minus 4 is negative 5. And if I put that into my calculator, I can see that negative 5 is equal to negative 5. It checks. Okay, now that we've looked at equations involving addition and subtraction, let's take a look at some equations that involve multiplication and division. So take a look at your foldable where it says equations involving multiplication. And we're going to just try a couple of these. We're not going to do all of them today. We've already spent a lot of time with the notes, but I want you guys to do some more practice. So we're going to do 2 of these together, and then you're going to complete some on your own. So if you look at the first example, 20 is equal to 4z. Okay, remember when you have a number next to a letter, it means you're multiplying, or a number next to a variable with no symbol in between. So again, we're trying to isolate the variable, which is z. Now I'm not going to subtract 4, just like you guys saw with the models that you're solving. If we're trying to isolate this variable, we're going to undo the multiplication. Okay, we're going to undo multiplication, and the way I do that is by dividing. So I'm going to divide both sides by the same number the variable's been multiplied by. So I have 20 equals 4z. So to undo 4 times z, I'm going to divide both sides by 4. When I divide 4z by 4, I get just simply z. And when I divide 20 by 4, I get 5. So my answer for this equation is going to be 5. I can put this into my original equation, and I get 20 is equal to 4 times 5. We're going to check to see if that's true. Yep, 20 is equal to 20, so it checks. All right, we're going to look at one more, and then I'm going to have you try some of the other ones on your own. So let's look at number 2, or one more for multiplication. And let's go ahead and take a look at that. We have negative 8 times g equals 24. Our variable's on the right side again. We're going to go ahead and highlight the variable to show that's what we're isolating. And again, this is multiplication, so we're going to undo multiplication by dividing. But notice this time we've multiplied by a negative number. To undo multiplying by a negative number, you have to divide by that same number. So we're going to divide both sides by -8. When we do that, -8 divided by -8 is 1. So we get g is equal to, and then I'm going to solve 24 divided by -8, which is -3. So that is my solution. I'm going to put it into my equation, and -8, original equation, times -3, and we're going to see if that's 24. So go ahead and put that into your calculator, -8 times -3. -8 times -3 is 24. 24 is equal to 24, so it's going to check. Okay, you guys are going to go back and do these two on your own. But right now, let's jump to number 5. In fact, I would like you to go ahead and pause the video, and I want you to write the equation, and go ahead and try to solve it if you like for number 5. So go ahead and pause the video, try it, and then unpause the video and we'll go over it together. All right, so the product of a number, we know that product means multiply. So although we don't always need a multiplication sign, I'm going to put it here. That means multiply. What are we multiplying? We are multiplying a number that we don't know, and we're multiplying that by 5. We know that the solution, it says the product of a number and 5 is, and we know that solution to be -35. Okay. So let's think. We're finding the product of a number and 5. So what we're doing is we're multiplying 5 and n. And remember, when we're writing algebraic equations or expressions, we don't need this multiplication sign. Because what happens is these multiplication signs look like x's and they can get confused in the equation, like for a variable. So we can just put 5 and n next to each other, and that is equal to -35. Okay, and so now to solve this equation, I'm going to draw my line down the center. I'm going to undo my multiplication. So I'm going to undo multiplying by 5 by dividing both sides by 5. And then n is equal to -7. Because -35 divided by 5 is -7. I'm going to take my original equation, 5 times n, which we found to be -7, is equal to -35, and 5 times -7 is -35, and we see that it checks. All right. The last type of equation, we're just going to look at a few of them, are equations that are involving division. We haven't seen as many models with division, but we are going to talk about how we will solve division equations on the next slide. So now we have equations involving division. We are actually going to do 2 of these. We're going to do number 6, and we're going to do number 8, and then number 10. We're going to do 3 of these. So if you'd like to go ahead and try them and pause the video, you may do that, or for this, you can go ahead and do these along with me. So the first equation, we're involving division. So we're going to undo division by multiplying. So you can see that we have division because we have the division bar for number 6. And it says we're going to isolate x. So x has been multiplied by 4. The way that we do undo multiplication is by division. We're dividing x by 4. The way we undo division is by multiplying. So we're going to multiply x divided by 4 by 4, and we're going to multiply 7 by 4. So we simply multiply both sides by 4. Now, when you multiply something that's been divided by the same number, it cancels out. So then we're left with x equals 7 times 4 is 28. So now we're going to check it over here, and I'm going to put in 28 for x. So 28 divided by 4. Again, I'm just taking my value for x and I'm putting it into the original equation, is equal to 7. And we're going to see if that's true. 28 divided by 4 is 7. 7 is equal to 7. It checks. All right, same thing, number 8, but the only difference is the variable's on the right, but we learned with the other examples that it doesn't matter. So I'm going to highlight my variable. I'm trying to isolate it. And I see that it's been divided by 2. So negative 12 is equal to r divided by 2. So I'm going to undo that by multiplying both sides by the same number it's been divided by. So I'm going to multiply both sides by 2. When I multiply this side by 2, it cancels out, and I'm left with 1r, which is what I want. And then I have negative 12 times 2, which is negative 24. I'm going to do my check. Let's see if it's right. So negative 12 is equal to negative 24 divided by 2. Negative 12 is equal to, let's see if that's true, negative 24 divided by 2 is also negative 12. So this one checks. And again, you're just undoing what's been done. These are division equations, so you're undoing them by multiplying. Just like with multiplication equations, we're undoing by dividing. Now let's look at the last problem. This time we are taking the quotient of a number, and negative 4 is 5. So you guys remember, quotient means to divide. So we're dividing quotient, and we're dividing a number. We don't know what the number is, so we're going to use a variable. We know we're dividing it by negative 4. So I'm just translating right here. And we know that it is equals, so we're going to use equals for is, and then we're just going to write that 5. Okay, so we're going to put all that together, the quotient. So we're dividing the quotient of a number and negative 4. And we know that's going to be equal to 5. Now I'm going to rewrite this with a fraction bar because typically you're going to see it with a fraction bar. So let's go ahead and rewrite that over here. So I'm going to have n with the fraction bar, negative 4 is equal to 5. I'm going to isolate my variable. N has been divided by 4. I undo dividing by 4. I'm going to multiply both sides, or excuse me, by negative 4. I'm going to multiply both sides by negative 4. Both sides by negative 4. So this cancels out, and n is going to be equal to negative 20. I'm going to do my check over here because I've run out of room. So my answer of negative 20, I'm going to plug it in. Negative 20 divided by negative 4. I'm going to see if that's 5. Negative 20 divided by 4 is 5. 5 is equal to 5. So it checks. Okay, now that we're done with the video, we've finished the ones we're going over together. I want you guys to go and do number 7 and 9 and make sure you show your work just like we've done in the video, and also your check. And then not only 7 and 9, but I want you to go back and do 3 and 4. So you can work on those now, and we'll review the answers tomorrow in class. That's it for our video on one-step equations.